Alright, welcome back to the second video of the ACT Math Skills video series. In the first video, we went over the first 18 skills, which I will link somewhere in a card. In this video, we're going to get into the next 14. Skill number 19 is about complex numbers. So the key to a complex number, by definition, it's a mix of a real number with an imaginary number. So an imaginary number is a number that has this I subscript in it. A real number is any number like, a positive or negative number, anything that doesn't have an I, okay? So a complex number is when you add these two together. So for example, a complex number would be like 3 plus I. This number, this quantity is a complex number, or 4I minus 3, okay? Those are examples of complex numbers. Now, you're going to be asked to do operations with complex numbers like this. So for example, how would you multiply these two out? So what you would essentially do is you need to keep in mind that I is equal to square root of negative 1. It's a concept that doesn't make sense. What you can notice about this is that if you square both sides, you get I squared is equal to negative 1. And you can use this to make this solution a little easier, okay? So let's do this. We're going to do foiling, first outer, inner, last. That turns into 3I times 4I plus 3I times negative 10 plus 4I times 1 plus 1 times negative 10. We can add those terms together. So this turns into 12I squared minus 30I plus 4I minus 10. We can combine the middle terms because they both have an I. You can treat the I like a variable, as if you're working with x, for example. And then this, remember, we can substitute I squared for negative 1. So this turns into 12 times negative 1 minus 26I minus 10. And you can finally combine these two real numbers. That turns into what's negative 10 minus 12, negative 22 minus 26I. Okay, this is your final complex number. So that's what this turns into. All right, so you need to be able to do this type of calculation. The other thing you need to also keep in mind is, so we know this rule that I just wrote down here, specifically this one. This is the important one. So how could you calculate I squared, I to the third, I to the fourth? So we know I is equal to square root of negative 1. I squared is just going to be negative 1. What about I to the third? What happens if we have a bigger exponent than 2? Well, this is just I squared times I, which is going to be negative 1 times I, which is negative I. Okay? I to the fourth is going to be I squared times I squared, which is going to be negative 1 times negative 1, which is going to be 1. And what you'll notice is if I do I to the fifth, it's just going to be equal to I. I to the sixth is going to be equal to I squared. I to the seventh is equal to I to the third. And this pattern goes on. So I to the n is equal to I to the n plus 4. So that's another thing you need to keep in mind. Okay, that will pop up on some problems. Moving on to skill number 20, properties of exponents. So just some rules to keep in mind when you have, I'm not going to walk through all these because there are a lot of them here, but you need to know all of these skills. So what I recommend you do is come up with an example, like a test case for all of these. So maybe plug in a equals 2, b equals 3, c equals, sorry, it's not a, b, it's x, y. And y equals 4, and do that for all of these cases, maybe even b equals 5, and you'll see that these are all true, okay? Some easy ones are, if you haven't seen this before, the easy ones that you can remember are any exponent a to the 0 is going to be equal to 1. So 4 to the 0 is equal to 1, 1,000 to the 0 is equal to 1, negative 1,000 to the 0 is equal to 1, etc. Okay? At least I think it would be. You can graph it to double check. Any exponent to the 1 is just going to be the original exponent, okay? So these are some examples. Again, create some test cases, plug in numbers, and you'll get to experiment with these a little bit. Factoring is another very important skill. So how do you factor an equation like this or one that's a little harder like this? So for an easier one like this, what you do when you factor is you look at factors of this last number, this number without the x. So list out the factors, 1, 3, 3, 9. The pairs are 1 and 9, 3 and 3, okay? So you look for factor pairs of this number that equal this number when you add them together, keeping in mind the signs, okay? So factors of positive 9 that add up to positive 6 when you add them together. So these can't add up or subtract to positive 6, but these can add up to positive 6. So our factors that we want to use are 3 and 3. And what we're going to do is plug in x plus factor 1 times x plus factor 2, and this is going to be our final statement, where we just plug in the factors now. So your final factored form is going to be x plus 3 times x plus 3. Okay, now if this problem was asking you to find, x-intercepts, and if this equation was originally set to 0, what you could do is set this equal to 0, and then these individual parenthesis components can be set equal to 0, And you can solve for the x-intercepts. In this case, you get the same answer, -3 for x. Okay, let's do the same thing with the second problem. Now this is a weird case because you have this 2 in front of the first term in the equation, so it complicates things. Now the way you're going to approach this is you can use the box method or the quadratic formula. I'm going to show you the quadratic formula, it's the next skill, but if you do the box method, this is how it goes. So you draw a box with 4 segments, kind of like 4 square. Put your first term in the top left, last term in the bottom right. You multiply these two numbers together, so this number and this number, you get 20, and then you list out the factors of 20. Okay, so factors of 20 are going to be 1 and 20, 2 and 10, 4 and 5. Okay, and we want to look for factors of this number, this product, that equal this middle number with the sign in consideration when you add them together. Okay, so these two factors, when I add them together, I get this thing, and when I multiply them, I get 2 times 10, which is exactly what we want. So we're going to have factors of 4x and 5x, and you're going to write these individually in these two last boxes. Okay, it doesn't matter where you write them, just make sure that whatever sign, you just keep in mind your signs. Okay, the last step is to find the greatest common, you're going to write 4 numbers here, okay, in these underlined, in these lined portions I just drew. You're going to write 4 numbers there. The number is going to just be the greatest common factor of each row or each column. Okay, so this number here is going to be the greatest common factor of this row. What's the greatest common factor? 2. What's the greatest common factor here? There's no number, but there's actually you just say x. Here it's going to be 2x, and then here it's going to be 5. Okay, I could go a little more in depth and kind of describe why we do this way, and go in depth on the box method, but that's something I do in my courses. So if you want a little bit more of an in-depth analysis and explanation, then I recommend you check that out. If this didn't make sense, and if you don't want to check out our courses, just use the quadratic formula for problems like this. You should be able to get away with it majority of the time. Okay, so that's how you do box method. Now quadratic formula, again, you can do the exact same thing that I just did. And what did we get here as our solution? So the last step is these statements right here are going to be your final factored form. So just to show you, if I set this equal to 0, that means that 2x plus 5 equals 0, and x plus 2 equals 0. That means x is equal to -2, or -5 divided by 2, so we get x equals -5/2. Okay, now if you notice, when we do the quadratic formula up here, you'll get the same answer. Okay, so if I take this equation written in this form, I can just plug in all my values into this equation here, and I'll get the same answer. So -9 plus or minus square root of b squared, which is 9 squared minus 4 times 2 times 10, divided by 2 times 2, we end up getting -9 plus or minus 9 squared is 81. 81 minus 4 times 2 times 10. So 81 minus 4 times 2 times 10, that is 1, square root of 1, which is just going to be equal to 1, divided by 4. So we get -9 minus 1 over 4, and -9 plus 1 over 4. Those are our two answers. What do those reduce to? -10 over 4, which is equal to -5/2, as I got down below. And this reduces to -8 over 4, which is equal to -2 is equal to x. And those are actually the exact same values I got down here. Okay, so quadratic formula and box method, they go hand in hand. You should get the same answer. Moving on to matrix operations. So how do you multiply two matrices together? In order for it to be possible to multiply two matrices together, the dimensions of the matrices have to meet a certain condition. So let me give you two sample matrices. 2, 1, 1, 0, 3. Okay, so this is when we look at the row by column dimensions of this is a 2 rows, 1 column. Okay, 2 by 1. This here has 1 row and 3 columns. 1 by 3, okay? So 2 by 1, 1 by 3. It is not possible to, actually it is possible to multiply these two together. And the reason is because when I write the dimensions out like these on top of each of the matrices, the two numbers in the middle actually equal one another, okay? That's how you know it's possible to multiply two matrices together. That's a very crucial skill that you need to know about matrices, okay? So if you want to check if two matrices are multipliable, which I just made that word up, you write the matrices out next to each other in the correct order, as the problem asks you to. You write the dimensions of row by column, not column by row, but row by column, above the matrices or below, and then you check if the two numbers in the middle are equal. In this case, they are, so it's possible to multiply them. And the last thing you'll notice is that the two numbers on the outside is going to give you, those are going to be your final dimensions. Okay, so the result of this matrix multiplication is going to be a 2 by 3. And now how exactly do you do the multiplication? Well, you're going to multiply across each row and down each column, okay, element by element. In this case, since this row has just one element, it's just one column, you're just going to be and also since this column has just one element, you're just going to be multiplying this value by this, and that'll be your top left of your 2 by 3 matrix. I remember I told you it's a 2 by 3, right? So there's going to be 2 rows, 3 columns. So this is a 2, and then your second spot is going to be this by this, so 2 times 0 is 0. Your third spot is going to be this by that, which is going to be 6. And then you do the exact same operation, but now with the second row. So you end up getting 1, 0, and then 3. Okay? That's how this works. That's how matrix multiplication works. I just drew this out here. The matrix dimensions should look like this. In order for them to be multiplicable, the middle numbers must equal, and the outside numbers will form your final dimension. Polynomial arithmetic is another skill on the math test. Basically, it's where they're going to give you a long equation with different variables and coefficients, and they're going to ask you to combine like terms or not combine like terms based on which terms are actually like. So the way you do this, when you combine like terms, you've probably heard this before. If you're not familiar with it, so look at the variables. So this has a variable of x squared. This has a variable of xy. Here you have a y squared. Here you have a xy again. Here you have x squared again. Here you have a y squared, okay? So can you just add all of these straight across, like 9x squared plus 5 this plus 1 times this plus 1 times that, 1 times this? Can I just add them all across and get like 15 or whatever it is, like 21xy squared x squared, something? Like that's not how it works, okay? There's certain terms that you can multiply together, or add together, sorry, and certain ones that you can't, okay? So you have to take it bit by bit. So let's start with the x squared only. You can only add the x squared to other x squared terms. So we have a positive 9x squared with a positive x squared. So I can add those two together because they have the same variable. The variable being the x squared. Okay, x to the third is a different one, x to the 1 is a different one. But x squared, specifically with an exponent of 2 and with a base of x, that's what makes them common, okay? Again, if this was an x to the third, this wouldn't work. But since it's x squared, it works. So I can add those together. That gives me 10x squared. All right, so let's write that down here. 10x squared plus something else, because I know we have 3 different types of variables. So let's do the xy, and then we'll do the y squared after. So the xy's, let's look at the xy's. I have a 5xy, a positive 5xy, and then I have a negative 1xy. And when there's no number in front, you imagine it's just an imaginary 1 in front of it, okay? So 5 minus 1 is equal to 4. That means I get a 4xy here. And then the last one is the y squared, positive 1y squared, negative 10y squared. So 1 minus 10, negative 9y squared. This is your answer, okay? That's how you do polynomial arithmetic, just combining like terms. All right, calculating slope and finding parallel and perpendicular lines. So you need to keep in mind this formula, y equals mx plus b. You've probably seen it before. If you haven't, it's okay. There's 2 components. The slope, which I'm not going to get into details of what exactly it is. You just need to identify it with this type of problem. And then here's your y-intercept, okay? Just remember that. M is slope, b is y-intercept. The m is going to be the value in front of the x when you write your equation in this order, where it's y is isolated and then everything else is on the right, okay? Your m, the value in front of the x, is going to be your slope. So if I give you an equation like this and ask you for the slope, you need to write the equation. You need to rewrite it into this form by shifting the terms around. We need to isolate y. How can we isolate y? Well, this 7x has to move here, and this 6 also has to move here somehow. So let's start by moving the 7x over by subtracting it. Since it's being added, we have to subtract it to have these cancel out. So 6y is equal to negative 7x minus 4. So you think, okay, the slope is negative 7, but again, this has to be y. It can't be 6y, because if it's 6y, then it's not isolated. If it's 6y, you need to divide everything by 6. 6, 6, and then 6 there as well. So we end up getting y is equal to negative 7 over 6x minus 2 over 3. This fraction, negative 4 over 6, reduces to 2 over 3. So your slope is negative 7 over 6. It's not negative 7 over 6x. It's not 7 over 6. It's negative 7 over 6. X is just the number or the variable in front of the slope, okay? That's how you do this. So keep in mind your terminology. The other thing is parallel perpendicular lines. So parallel lines have same slope. Perpendicular lines have slopes that are negative reciprocals of one another. That sounds complicated. Let me show you that it's actually very simple. So imagine I have a line that has a slope of negative 7 over 6. So if there was a line that was parallel, it would also have the same slope. But if it was perpendicular, it would have a slope that was negative, the negative of this first. So let's first make it negative. So it's going to be flip the sign, and then let's take the reciprocal. The reciprocal is where you flip the numerator and denominator, okay? So it'll just be 6 over 7. So two lines, one with 6 over 7, and the other with negative 7 over 6, they will be perpendicular lines. So if I drew them in the xy coordinate plane, they would look like exactly like this, where this is a 90 degree. Okay, I just can't draw straight, but you get the point. All right, so that's how perpendicular and parallel slopes work. The one thing you should notice is if your slope is not a fraction and you're trying to find the negative reciprocal of a number like 3, well, it's actually a fraction. It's just 3 over 1. So this is going to be negative 1 over 3 perpendicular. Simple algebra and distributive properties. So simple algebra, just solving equations like this. This looks complicated, but really what you do is you just cancel out the 3's here, because in order for 3 to the something to be equal to 3 to the somethings up there need to be equal to one another, right? Like in order for 3 to the 2 to be equal to 3 to the x has to equal 2. X can't be any other number, otherwise it's not equal, right? So in this case, you can ignore the 3's. Ignore the 3's here. So it's just 3x plus 7 equals 15. Maybe this is one of the skills I should have done earlier in the series because it's very simple. It's one of the more important base skills you need to know. So what you do to solve this for x is you want to, like I said, isolate x. So what's happening to x right now? There's a 3 that's multiplying it, and then after it's multiplied, there's a 7 added. So let's go in reverse order of that. We want to first get rid of the 7, move it over to the other side. So 3x is equal to 8, which is 15 minus 7. And then we want to get rid of the 3. Since right now the 3 is multiplying x, we want to divide by 3 so the 3's cancel out. And you end up getting x equals 8 over 3, which is 2.6, I believe. All right. Now, you could also get more complex distributive property problems like this one. So in this case, what you do is you want to distribute this here, right? And then afterwards, this will turn into a 2-term thing, and then you can FOIL that out to this last term. So let's just do that. Let's start with just doing this right here. So 4x times 3x is 12x squared, and then 4x times 2 is 8x. And now we're going to multiply that by x minus 1. So again, we're just FOILing first outer, inner last. So it's 12x to the third now, minus 12x squared, plus 8x squared, minus 8x, okay? And last thing is combine like terms, just like with polynomial arithmetic. These two middle values have the same exponent of x to the second. They have the same variable x to the second. So 12x to the third minus 4x squared minus 8x. That's your answer, okay? That's how you do simple algebra and distributive property. Moving right along. So when it comes to solving and graphing inequalities, I give you a weird inequality problem here. And what does this equal? So it looks odd, but it's actually very simple. So you just treat it like a regular equation. Imagine these are equal signs, but imagine you have 3 different sides to the equation. So you're just doing simple algebra, but with instead of 2 sides to the equation, you have 3. So the key is I want to isolate x. So let's start by subtracting 1 from all 3 sides. So we get 2 is less than 4x is less than 9. And then the last thing that's happening with x is it's being multiplied by 4. So divide all sides by 4. Okay. That turns into half is less than x is less than 9 over 4. And this is your final answer. The only other case where this gets kind of complicated is if this was a negative number. Let's do the whole problem again with a negative here. So we're subtracting 1, subtracting 1, subtracting 1. 2 is less than negative 4x, less than 9. Now we have to divide by negative 4 instead of positive 4. So you're going to end up getting negative half is going to be less than x is less than negative 9 over 4. But now what happens is when you multiply or divide an inequality by a negative number, just like I did here, I divided it by a negative number, you actually need to flip the signs of the inequalities. So your actual inequality is going to be this. And you can write it in reverse just to make it a bit more clear. So you have negative 9 over 4 is less than x is less than negative half. These two are the exact same thing. I just wrote it from right to left versus left to right, okay? I prefer having my alligators opening it onto the right. That's just conventional. And you look at the ACT answer options will usually have it that way if it's a compound inequality. Okay. Now, another step up in terms of complexity is the absolute value inequality. So it's where you have an inequality statement, but there's also absolute value brackets there, okay? So the way you're going to solve this is first isolate the absolute value. So now we have absolute value of x, 3x plus 4 is less than 20. Now you're going to get two different absolute value expressions. The first one's going to be the original expression just without the brackets. The second one is also going to be the original expression without the brackets, but replace the brackets with parentheses and then put a negative on the outside. And then just simplify both. So this turns into 3x is less than 16. X is less than 16 over 3. This turns into negative 3x minus 4 is less than 20. Add 4, add 4. We get negative 3x is less than 24. So we get x is less than negative 24 over 3. We also have to flip the sign because it's a dividing by a negative 3. So it turns into x is greater than 8. Okay? X is greater than negative 8. So that's how you do this problem. X is greater than negative 8. X is less than 16 over 3. Graphing inequalities in the xy coordinate plane. So a couple types of inequalities that you should know how to graph. One is a circle. The other is a line, okay? So let's start with the line. The line is a little bit easier. So if I draw an xy coordinate plane, so there's a couple main factors you need to keep in mind. So solid versus dashed line. And then which side of the line? To shade on. You also want to make sure that you're like if you're doing a problem like this and it asks you to shade this, you want to make sure that your answer options actually have the correct graph. Okay, that's key. Okay, so three things to consider: solid versus dashed, which side of the line to shade on, and then do the answer options have the right graph. So first of all, we want to make sure we have the right graph. Your graph's going to look something like this. A slope of 3 will be kind of steep. I'll do it in a different color for not confusing everyone. Okay, there we go. It's 3x plus 4, so it'll be up here. Let's say this is 4, right? Now, that's the first thing. Now, solid versus dash. So technically, since this is a greater than without being a greater than or equal to, if it doesn't have the equal to, like if it has the equal to, then it's a solid line that you put the graph as. But if it has if it doesn't have the equal to symbol there, then it's going to be a dashed line. So in this case, I should actually use a dashed line, okay, when I graph it. So let's redraw that with a dashed line. There you go. Okay, first step is complete. Got that right. Which side of the line to shade on? So this is actually very easy. So look at the y-axis really quick. There's two sides of the y-axis. There's the one that goes up and one that goes down. The part that goes up goes on forever, right? This y-axis is just a concept that says it goes infinitely up and it goes infinitely down. It goes infinitely up to positive infinity and it goes infinitely down to negative infinity. So when it comes to graphing a line or any equation where you have y is greater than something or y is less than something, where y is isolated, what you do in order to shade correctly is if y is greater than, you shade on the side of the y-axis that has positive infinity on it. So look at this graph. Positive infinity is here, and it's clearly on this side of the graph. Negative infinity would be when y is less than. So if this line, if you get an inequality that's like y is less than x squared, and if I draw x squared, negative infinity is down here, right? So we're going to shade below the graph. Everything here is going to be blank. Okay? So that's the simple convention that you follow for shading on either side of a graph that is a line. Okay? So in this case, we're shading above. So just highlight above. I didn't highlight it perfectly, but you get the point. That's done. The line, is it the right graph? Like I said, I already made sure that it has a visual slope looking like 3 and it has the right y-intercept. If my y-intercept was like down here, and there's an answer option that you see that's like this, then you clearly know it's wrong because you're trying to graph plus 4, not minus 4 y-intercept. Okay? Now let's do the same thing with a circle inequality. So I'm going to draw a graph. All right. Circle inequality. So first you should know how to graph a circle. If you don't, we'll go over it at some point in the series. I think it is going to be in the next video. So it should be part 3. Okay. So let me first draw my graph. It looks like the center is at 3, negative 2. So over 3 down 2 right here. Radius is 4. So this is another key. We're trying to make sure that we have the right graph. So if I know that this is 3, negative 2 and the radius is 4, the radius should go past the y-axis because this distance right here is 3, right? This is 3 from the origin. So my radius should go past this, and it should definitely go past this because this distance is just 2. So keep that in mind when you're plotting these graphs. Okay, so we have the graph in the right spot, approximately. That's done. Which side? So which side do we shade on? So with circles, it's weird because you have y on this side, but you also have x on this side. So it's not like y is less than or greater than something. It's actually x and y with a bunch of other numbers are greater than just this one singular number. So how do we do this? So there's an easy way to think about it. If your x's and y's are less than your radius squared, because again, remember, this is the radius squared. So if your x's and y's are said to be less than the radius squared, you're going to shade inside. You can interpret that as you have this radius out here, and your x's and y's are limited by the radius because they are less than the radius. Okay? So an easy conceptual way that's intuitive to think about it. If this was instead a greater sign, that means that your x's and y's, the side of the equation with the x's and y's, is greater than the radius squared. So you can interpret that as, okay, my x's and y's are not limited by the radius. Actually, the radius is going to be smaller than my shaded area. Okay? So that's how this works. Moving on. Converting units. So usually converting units problems are going to be working with units that generally students, like in the average sophomore, junior, senior student should know about. So here we're working with inches to feet. In this case, it's actually square inches to square feet. You could get square feet to square yards. I've seen that before. So this is kind of a little bit harder example, but I'm still going to throw it at you because why not? So it says, there's a couple ways to approach these. There's like a visual method, which I'll show you. There's also a correct unit kind of conversion method, like a mathematical method. You get the point. Okay, so a screen has an area of this. So what is the area in square feet? So 334 inches squared. If you think about it, 1 square foot, so let's say this line is a foot. This line is also a foot. Actually, let me just draw a square. That might be a smarter thing to do. Okay. So this foot can be divided 12 times, right? With each segment equaling 1 inch. Same thing here. I don't know if it's exact, but it's 1 inch. If I got that exactly, then leave a like down below for just immense accuracy. That's skill. Okay, but you can essentially draw a grid, right? Each of these lines represents, one of those inch lines, and you'll realize that within 1 foot squared, this 1 foot squared, you actually have a grid of 12 by 12 inches squared. So 1 foot squared is actually equal to 144 inches squared. Again, just through the visualization, we can kind of observe that, right? So if I know that 144 inches squared are in a foot squared, then I can essentially divide this by this, and I'll get the essentially how many feet squared I have. 334 divided by 144, and you'll get the right answer, okay? The way you can check if you're doing the division correctly, okay, why wouldn't you do 144 divided by 344 or 334? How do you know what order? So your units have to cancel out. So if I do 144 inches per foot squared, and if I divide 334 inches, let me actually kind of erase this a little bit. It's getting a little bit much, don't have enough space. Okay, so let's describe the units a little bit, and this will take me into the kind of analytical mathematical way of doing this correctly. So 334 inches squared and 144 inches squared per foot squared. Okay, I want you to interpret this as 144 inches squared divided by 1 foot squared. Okay, so if I divide this right here by this right here, what am I actually doing? You're multiplying this by the reciprocal of this. 1 foot squared over 144 inches squared. And what happens to your units is that if you just look at the units here, the units multiply out to inches squared times foot squared divided by inches squared. Inches squared will cancel, you'll get an answer of foot squared. Okay, so when you convert units, you can think of it this way as I need my units to match up correctly. So I'm going to order my multiplication in a way where the final answer makes sense. Okay, so you can kind of reverse engineer the problem that way. On the flip side, if you had done it this way, so if you had put 144 inches squared up here and 1 foot squared down here, what's your unit? It's inches to the fourth divided by foot squared. That does not make any sense. Okay, so that's how you do that. And that's basically the analytical method of doing it. So another analytical way that I'll kind of walk you through is, so when you're converting units, I want you to write your desired unit here and put a blank. So blank feet squared is going to equal to parentheses, a fraction in here with the desired unit in the numerator, the old unit in the denominator, and we're going to have another parentheses with just a number, which is your inches squared, okay? Here you put your original number, which is 334 inches squared. Here, this is a fraction, like I said, so you're going to put the unit conversion. So how many feet squared are in an inch squared? You need to know this. So I know it's 1 foot squared, 144 inches squared. Now, if you don't know that, you can just do it in terms of feet and inches. I know 1 foot, 12 inches, and I could just square it after. And this thing right here will actually just turn into 1 over 144, feet squared over inches squared. Okay? And the last step is you just calculate this, make sure units align, which they will. You're doing feet squared divided by inches squared times inches squared. Okay? And when you multiply that out, you'll get your answer. Whatever this number is, I don't know it, but that's the answer. Okay, finding and using patterns and sequences. So here is an example problem. There's a lot of different ways this could show up. There's probably like 2 or 3 main problem types. Here's just one of them. I'll walk you through it. Okay, so it's a geometric sequence, which means that the parent equation looks like this. R to the n minus 1. It says A50 is this and A52 is that. So how do we get A48? Here's the basic way to do it. So first create 2 equations, one for each of these kind of data points. So A50 is going to equal to A1 times R, which I don't know, to the n minus 1. N is going to be 50, so n minus 1 is 49. Okay, and this is equal to 4. A52 is equal to A1 times R to the n minus 1, which is 51. That's equal to 16. What I'm going to do is let's move this down here. I'm going to actually divide the first equation by the second. Okay, so just ignore this right here, because I have my equation sign, the equal sign on the other side. So the A1s will cancel out. So we get R to the second is equal to 4. And that gives you your common ratio. The whole issue with this problem is that we don't have the common ratio, right, in this equation. In order to use this equation, if I want to calculate A48, I know n is equal to 48. So I have this, but I don't have R and A1. So in order to calculate one of those, you can essentially divide like I just showed you, and we get R equals 2. All right, now the other step is to find what A1 is equal to. So just plug in these test cases with the R value and you can find A1. So A50 is equal to 4. So 4 is equal to A1 times R to the 49. Just divide that out. So A1 is going to equal to a very small number. It's going to be 4 over 2 to the 49, which is going to equal to 2 squared over 2 to the 49, which is going to equal to 2 to the 2 minus 49, which is negative 47. Okay, that's equal to A1. Now that I have A1 and I have R, I can just plug everything into this equation and I'll get A48. Okay, very simple, straightforward. It's just you have to practice that process a bit. So I recommend if you are on your own, you can go to a geometric sequence calculator and create some sample problems for yourself, or just buy our course. We have problems like this as well, so you can try it out and you don't have to do everything I just said. But if you don't want to do that, you can do it yourself as well, and it'll work. All right, good luck. So we are on the last skill, finding domain, range, and vertical asymptotes. I really like this skill. So what is domain, range, and vertical asymptotes? Domain is all possible x values that the equation will reach. So you might think, okay, any equation will be existent at any x value, but how about an equation like some equations, what's an example of an equation that doesn't exist at every x value? Yeah, I'm blanking right now. Okay, if you look at y equals ln of x, okay, this equation looks like this. No, it looks like this. Okay, it doesn't exist anywhere on the left-hand side. So that it doesn't have, the domain is not all real numbers all the time. Range is just all the set of y values. So for example, not every equation has a y value at every possible y value. Sine x, for example, looks like this, approximately. It's not perfect. So the y values are limited to this channel, which is usually just positive and negative amplitude. Okay, so range, those are things you need to be able to notice. Now, one typical way that this is asked is through problems like this. So what are the following, what are the asymptotes? So asymptotes are basically the x values that form, so some graphs, you have this behavior where the graph looks like this. Okay, the graph will look like this. So this behavior where it goes up to infinity and it goes down to negative infinity at this line right here, that line could be anywhere. It doesn't have to be right at the y-axis. It could also be like y-axis, x-axis. You have a line here, you have a line here, and there's like imaginary line that they're kind of, these equations are kind of staggering. They're kind of approaching, but they're never reaching. So that line, this thing is called an asymptote. It's an asymptote. It has the word simp in it. That's how you can remember it. Okay? So that's an asymptote. Now the way you calculate it is essentially you look at the original equation, you simplify it first. So this actually can be simplified. You can factor the denominator, factor it as x plus 3, x minus 1. Okay, so now your equation is x plus 3 over x plus 3, x minus 1. You'll notice x plus 3 cancels out with this, 1 over x minus 1. This is your simplified equation. So any x value that makes the denominator equal to 0 is going to be an asymptote. So x minus 1 equals 0. That means you're going to have an asymptote at x equals 1. So if I graph this equation, it's going to look like something, something, something. And then at x equals 1, you're going to get some behavior that looks like that. It might not look exactly like that, but it'll look like that. Okay? So just keep that in mind. That's how asymptotes work. And as far as the domain is concerned, the domain of this equation is not all real numbers. This equation has no value at x equals 1. Okay, it has no value. It's essentially positive or negative infinity at the same time, and there's no value there. Another thing about this problem is, as it's written here, x equals negative 3 is still technically in the denominator, and it'll make the denominator equal to 0 with the original form of the equation as it's written. So that means that x equals 3, it's not in the domain either, but it's also not an asymptote. Okay, so it's kind of in the middle. It doesn't impact the appearance of the graph, but it's still not in the domain. So at x equals negative 3, you're going to have essentially just this hollow dot. Okay, that's how you signify this type of other hole, literally a hole in the domain. Okay, so that's how you do these next, I don't know how many skills I just went over, like, what was it, 14? So yeah, hopefully this was helpful. Let's shift to the outro. And that's about it. So good luck with the ACT, and I'll see you in the next video where we discuss the next ACT math skills.